Hey everyone, welcome back. We're going to start our journey today with this video moving into Chapter 9. And in Chapter 9 in our CPM, Common Core Algebra book, we are going to start investigating some additional ways of solving quadratics. And that's exactly what we're faced with here in this video on 9.1.1. We're going to start, as always, with some modified notes. I've taken some things and highlighted some important concepts. I'm going to walk through a couple things very intentionally, and we're going to use question 9-1 and kind of review some of the places that we've been with the zero product property. Remember, we've got a quadratic here, and some of these things are set up very conveniently for our purposes. A quadratic in A, a quadratic in B, and a quadratic in C. And all of these things are solvable, and we're going to use the zero product property to do so. And I'm actually going to start with letter C right here. I'm sorry, letter B. Then I'm going to go to C, and then I'm going to tackle A, because we're going to move into the next problem with A. So zero product property, remember, says that if we have a product of things that equals 0, then one thing or the other has to be 0, right? It's the only way we can make it. Well, let's look and see if we meet those conditions. I have 0 over here on the left-hand side, and then I have the product of 3, the product of x and x minus 5, and the product of 2x plus 3. All three of those things multiplied together makes 0. So here's what the zero product property says. It says, okay, then one of those three things has to be 0. This, or this. Well, let's consider it. Is it the case where 3 equals 0? Well, we know that can't be true. That's not the case. That's never been the case. That's not a solution for us. But it could be the case that x minus 5 equals 0. Well, if x minus 5 is 0, then what do? We're going to add 5 to both sides, and then x is equal to 5. There is a plausible solution. But it also could be the case that the third thing is equal to 0. It also could be the case that 2x plus 3 is equal to 0. All right, well, then we subtract 3 from both sides, and we get 2x equals negative 3. Now I haven't solved for x yet, so finally I'm going to divide both sides by 2, and I get x equals negative 3 halves, or negative 1.5, or negative 1 1/2, however you like to write that. I have one solution here and a second solution there, okay? This, of course, is not a solution. All right, and there we use the fact that the product of two factors equaling 0 means one of the two factors has to be 0. All right, we're going to go ahead and move over here and tackle C, ladies and gentlemen. And in order to tackle C, I've actually got to do some factoring. Now, I don't have a trinomial, so I'm not going to be able to factor this thing using, our trinomial factoring pattern that we've seen. So what I'm going to do, just to remind you, is I've got an x squared, I've got a 6x. I'm asking myself, hey, what factor do those things have in common? And they don't have a number in common because, factoring out a 1 from the 6x does not really do anything for me, but they do have an x in common. So if I drag an x out, then I can write a binomial of what's left. Well, if I factor an x out of here, I'm just left with an x, and if I factor an x out of here, I'm left with a 6. Now, if I wanted to, I could certainly redistribute that, and it would definitely be the case that it does work out to be x squared plus 6x, but remember, I'm factoring here for the purposes of solving, so that doesn't necessarily do anything for me. Now look what we have. We have x times x plus 6 equals 0. Again, the zero product property is going to help us out. I've got the possibility that x is equal to 0, or I've got the possibility that x plus 6 is equal to 0. Now, over here on the left side, where x is equal to 0, this is already done. There is one solution for me. But over here on the right, just a tiny bit of work. I'm going to subtract 6 from both sides, and I do have the chance or the possibility that x is equal to negative 6. There's my second solution. Okay? Finally, folks, we're going to move on to letter A. And letter A is, it looks like this. It looks great, but unlike B and C, it is not equal to 0. So we're going to have to do a little work here, and the work I'm going to do is going to start getting this thing equal to 0. Now, I do want that 9 to cancel over here on the left, so what I'm going to do is I'm just going to subtract it from both sides, and I have to make sure my math is sound here. Okay, so I'm going to do that. All right, now we're in a position where we're probably getting pretty good at factoring, probably getting pretty reasonably good at factoring. So if you want, you can go ahead and you can build the generic rectangle. I'm sorry, build the rectangle with algebra tiles here. Otherwise, you can do what I'm about to do, which is just jump to the generic rectangle for the purposes of solving. So let's rehearse that, right? We're going to have a generic rectangle. I always make these 2 by 2 for a trinomial, right? Because we're trying to factor this trinomial into the product of two binomials. So I've got a 3x squared and I've got a negative 15. That's the pattern that we've embraced here. Now I'm looking for two things, right? I recognize that 3x squared times negative 15 works out to be negative 45x squared. That's just something I'm keeping in my brain. So what I need here is I need a couple of numbers that when I multiply them work out to be negative 45x squared. It has to be. But they also need to add up to a positive 4x. Okay, so let's check these things out, right? Couple things I remember about the number 45. It's got factors, right? 45 has factors of 1 and 45. It's got factors of 3 and 15, and it's got factors of 9 and 5, or 5 and 9. Maybe I should write those that way. 5 and 9. Okay? Now look at that. Any way I can take those and make a positive 4, and ding, 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 I definitely can. Watch this. If I write these as a 9x and a 5x. Now I know what you're screaming at your computers. You're going, Anderson, that doesn't add up to 4, but it does if I make the 5 negative. Because remember, 9 minus 5, or 9 plus negative 5, is positive 4, and 9 times negative 5, that multiplies to be the negative 45. So if I do this, now I've got this generic rectangle set up right. It meets this condition right here, and it meets this condition right there, and now we're just going to talk about some dimensions. So what are the factors that 3x squared and 9 have in common? Well, they definitely have a 3x, so I'm just going to kind of plunk those things out, and I would then multiply this by like a, like 1x and a 3, and then in order to get this to work out, 1x times negative 5 works out to be negative 5x, and 3 times negative 5 works out to be 15. So what I have here and here are the appropriate factorizations. Let's just go ahead and write them real fast. It's going to be, you know what, and I want to write this below here. It's going to be 1x, or x plus 3, times 3x minus 5. And that, of course, is that area as a product. And now, ladies and gents, we'll just take that zero product property, and we will go x plus 3 equals 0. And we'll have 3x minus 5 equals 0. And now it's time to solve. Okay, so we're going to subtract 3 from both sides, and I get x equals negative 3, and I am going to add 5 to both sides here and here. I got to scroll down. 3x is 5, and now divide by 3, right? I got to take an extra step here, and I get x equals 5/3. So I've got a first solution of negative 3, and I've got a second solution of 5/3. Okay. Now, ladies and gents, A is really what we cared about. A was the one that I wanted to get done so we could further investigate some items here in the next part of this video. And it's going to be in problem 9-2, but we're going to use what we did in A. Now, real fast, I'm going to highlight these answers for us because I want to keep them in mind, okay? Negative 3 and 5/3, because as we move on here, we're going to move into another connection, okay? Let's use your calculator to verify the original solutions before rewriting them, okay? And we're going to use A, right? A is where we had 3x squared plus 4x minus 6 equals 9. And we're going to use the graphing calculator. I'm actually going to use Desmos.com to do this. And this is conveniently loaded up in our eTools. So here I go back to my ebook, and I've got this 9-2 eTool, and I click on it, and it's already entered in here for me, and I have the graph loaded up. It looks great. Okay, one thing I like to do here is I like to turn on the projector mode from Desmos. It just makes everything a little bolder. Okay, and then when I go ahead and do my work here, I've got some, work to do. But it says graph it. Well, that's already done. Okay, but it asked me the question here, where am I going to be looking for the solution? This is the part that we may need to do some thinking on, because remember, it wasn't equal to 0 when I started. It was equal to 9. So keep that in mind as we get moving forward here. Okay, and then it says, where can we look in the table? Well, conveniently, because I use the E tool here, it's already loaded up in the table, and I don't know if you guys see anything in this table here, but whoops. Okay, I mean, not whoops, I mean that's a good thing, but let's go ahead and start to investigate this. I've got some roots here, and these roots are super duper important. If this was equal to 0 for the purposes of solving, but it's not, it's equal to 9. So here's what I am going to do, because I have this liberty. I'm going to go ahead down here, and I'm just free-forming. I'm going to go ahead and I'm going to add a line to this. I'm going to add the line y equals 9. This is the other side of that equation, right? If I click back here, you guys can see this was this side. This was this thing that we started with right here. Oops, I gotta grab my pencil. It was this thing right here. It's the 9. Okay, so look what that does. It creates a horizontal line. Like the x-axis, it's horizontal, and it creates two intersections with my parabola. Now, these intersections are important for me. Check out what's going on. If I click right here, it identifies that intersection. If I click right here, it identifies that intersection. Now, what do you recognize about those points? Clearly, the y-coordinate of both points is 9, right? That doesn't escape any of you. However, what do you notice about the x-coordinate? The x-coordinate here, pretty gosh darn easy to see, is -3. The x-coordinate here is 1.667, or 1.6 repeating. Those, ladies and gents, are the solutions we identified using our algebra back here. -3 and 5/3, right? Because 5/3 is 1.67, or 1.6 repeating, okay? So there's how we can see that in the graph, okay? If I want to see that, notice what I did. I just graphed the horizontal line, y equals my solution value. In this case, it was 9. The second question they ask here is, where can we see this in the table? Well, we already identified, hey, I can see this right here. I can see it, this -3, 9, it definitely matches that point. It's on both of these functions, right? It's on the line y equals 9, it's on the parabola as well. So it's a solution. Okay, but this one we're not going to find in the table, and I don't know if you guys saw this. Like, I'm just going to keep going here. If I want to extend my table, right? You might have extended your table and just you're looking for it, and why not? Well, watch what happens when I turn this table on. Okay, you're going to see here that I don't have, if I turn the table on and my table's purple, I don't have a point right on that intersection. I did right here, but I don't here. Now, why is that? That might jump out at you, because it is a rational number. Okay, it's a rational number. It is not going to appear in this table of integer values unless I go ahead and add it. Now, here's the gist. Okay, I've got a 1.5 right here. I've got a 1.8 right here. I can see that solution occurs somewhere in between there. That would be a great idea for the purposes of estimating. Okay, alternatively, if I wanted to, right, I could also estimate like this by typing in what I think that solution is, 1.667. Now look at how close I get. That's not exactly 9, because remember that rational number is 1.6 repeating, but I get really close. Okay, last thing that I could do, and this is I'm going to turn this off. This is another, I'm going to get rid of this as well. Another option for you. Okay, I could change this to be our modified function. And when I do that, there's my -3. There is my 1.667, right? Just by changing that to our modified value of 15 when we subtracted 9 from both sides. Ladies and gentlemen, we do have a tiny bit of review preview for you. Want you to try these things. Whoops. want you to try these things so we know what kind of questions we have, right? Just 6, 7, and 8. Thanks for watching. Have a wonderful day.